So in the previous video, I made a 3D game engine, and I added 3D physics to the engine using the Jolt physics library. But I needed to add 2D physics too, since I want to have both 3D and 2D in the engine. So I thought about using Box2D, which is a super popular physics engine that everyone uses. But I heard a story online about how the developers of Rain World had to build their own physics engine because Unity's physics, which was Box2D, didn't support what they were going for. So now that I had an excuse, I decided on building my own physics engine, since I want to make a game like Rain World. The first part to getting started was to add a sprite renderer component, since 2D rendering doesn't actually exist in the engine, and so I quickly got a test scene up and running. And then I made a rigid body component. And the rigid body is just a physics object which doesn't get deformed. And I made a system to loop over all rigid bodies and apply Newton's laws to them. Velocity is equal to force divided by mass, and position gets incremented by velocity every frame. And the same is true for angular velocity as well. And both of them are multiplied by delta time, since that's the time it took for the frame to finish. If they weren't multiplied by delta time, the physics would run way faster at a higher frame rate, because more physics cycles would be run in a single second because there would be more frames. Now the dynamics are working, but that was just the easy part. Now it's time for collision detection. To keep things simple, I only added an AABB, or axis aligned bounding box for now. And if you don't know what that is, it's basically just a box that doesn't rotate, since rotations are hard. And to detect collisions between two AABBs, I made this function to provide some data for the collision, and this collision data is also called a manifold. And the final result looks like this. And as you can see, it doesn't really look all that great. It kind of looks like we're floating in water. And the reason this is happening is because I implemented a sloppy solver that just pushes the body upwards whenever a collision is detected, since I haven't made an actual solver for now. But at least the collision detection works, which is great. And the way that the collision detection is working right now is that I'm checking every rigid body with every other rigid body. This is the most simple solution you could come up with, but it's also the worst, since if you have 4 bodies, you'll have to perform 16 checks. This solution has a big O of n squared, which just means really bad. So how do you come up with a better collision detection algorithm? Seriously. I'm asking you because I have no idea. And to Google I went in search for better algorithms. And I came across an algorithm called search and prune, where you only search for collisions on certain axes. And then I came across a spatial partitioning technique called quad trees, where you divide the world up into boxes, and for any given rigid body you make 4 new boxes inside the box that the rigid body is in, and you want to check for any boxes that have more than one rigid body. But then I wondered what Box2D used, and it turns out that they use AABB trees. AABB trees are a spatial partitioning technique where you enclose every rigid body inside an AABB. Then you enclose 2 or more rigid bodies inside an AABB that encompasses both of them. And you want to keep going until you have every rigid body enclosed inside a root AABB. This sounded interesting, so I went with it. And I found this paper on AABB trees, which was written by Erin Caro, creator of Box2D and the frickin' man himself. And the AABB tree would work like this. We insert a rigid body into the tree, and the tree finds the best possible sibling rigid body, and it makes a new parent AABB for both of them, and adjusts the ancestor AABBs to fit the new parent. And the way that the tree finds the best sibling is that it descends down the tree from the root node, checks both children to see which one would have less perimeter length if they unionized, and the one with less perimeter length is descended down upon until we reach a leaf node which has the least perimeter length, and we can make that the sibling. And so I followed the paper implementing the AABB tree, and eventually it works. The tree removes and reinserts rigid bodies that have moved into it so that it can be updated. But enough talk. I haven't actually implemented the traversal of this tree to detect collisions, which is kind of the entire point of the tree, so I made a function which goes down the tree, and any AABB that it finds which has 2 leaf nodes in it will be performed a check on, and it will add the manifold to a vector of manifolds which it then returns. I also made a solver function to solve all these manifolds, adjusting the positions of both objects to distance themselves to resolve the penetration. And after testing it out, it's pretty much working now. Wait, no, it's not working. And after a day of banging my head against the wall, I realized that the way my collision detection algorithm works is that it only performs a check on 2 bodies that are inside an AABB, which means if a body is further up in the AABB tree, it's not going to check if the lower body is colliding with the upper body, because they're not in the same node. So I adjusted my algorithm to be recursive in checking for bodies, and it finally works. Then I added circles to diversify our list of colliders. They're pretty cool, but they don't roll around, which is a large part of circles' identity. So I added angular velocity to the solver, and now they roll around. Very cool. And while having AABBs is nice, they get kind of boring since they can't be rotated, which isn't very realistic. So instead of having axis-aligned bounding boxes, we need to have object-oriented boxes, or OBBs. These bad boys can rotate, which is just what we want. And I tried really hard to implement these guys, but they just weren't working out for me. Either it was having a seizure, or it was transcending the mortal plane and phasing through reality. This little guy was just not a big fan of Newton and his laws, so I scrapped OBBs and began work on polygons. Box2D also uses polygons, not OBBs, so I'm really just copying everything from Box2D at this point. And I represent the polygon as a vector of points in local space and a vector of points in world space. The local space points don't move, but the world space points do. And the local space points get converted into world space when the polygon moves or rotates. And for the polygon collision detection, I used the separating axis theorem, which states that if 2 objects are not colliding, there must be an axis where 2 points of the objects are separated. The way the algorithm works is that I project each point of object 1 with every other point of object 2 on a single line, and see if these 2 points overlap each other on the line, and if they do, the objects are colliding. We repeat this for both objects, and after implementing the algorithm, this is the result. The polygons are just squares in this clip, but they can be any convex polygon, since the separating axis theorem only works for convex polygons. And I swapped 1 polygon out for a triangle, and that seems a bit weird. The triangle's just bouncing around. I'm gonna be honest here, I have no idea what I did to fix this, but it works now, and that's all that matters. Also, to improve performance, I added an awake flag. Any body whose velocity is less than a certain threshold, they haven't moved. And in the collision detection, if both colliding bodies haven't moved, then they're both put to sleep. But if one has moved and the other hasn't, then the sleeping one is set awake. It's a sloppy solution, but it works for now. And that's pretty much it. Thanks for watching. I hope you learned something from this video. I know I did, and if you've made it this far in the video, please consider subscribing or liking the video, as that helps me tremendously. Also, this project is up on GitHub. It's in the SlugInTub repository in include/smtd. Also, the engine has changed a lot since this video. That's because I've been working on it. And hopefully, I'll see you in the next video. See ya.